Hello and welcome to today's produce safety webinar on a basic introduction to mushroom growing, harvesting, packing, and holding as it relates to the produce safety rule. As indicated, my name is Kristin Esch and I'm with FDA's Center for Food Safety and Applied Nutrition Produce Safety Network, and I will be your moderator today. This presentation, again as indicated, will be recorded and sent out to everyone that registered, as well as uploaded to the FDA website and YouTube channel. We will have time for questions at the end of the webinar. Please feel free to enter your question at any time in the Q&A box. Today we will have speakers that will be discussing the basics of growing, harvesting, packing, and holding practices for mushrooms, specifically white or button mushrooms as it relates to the FSMA produce safety rule, as well as have a state perspective of conducting produce safety inspections on mushroom farms. There will be a very short discussion as well on specialty mushroom practices. We have a lot of participants on the webinar today, and I appreciate the enormous interest in this topic. I understand that there are many questions around mushrooms. However, today we will need to focus our time on the aforementioned topics and any questions related to that. Unfortunately, we will not have time today to get into any other topics, but you can always send in your questions to the FDA Technical Assistance Network at FSMA@fda.hhs.gov. To start us off, I'm going to begin with a very short overview, and then I'm going to turn it over to Dr. John Pecchia, who will spend the majority of today's time discussing the basics of mushroom practices. Dr. John Pecchia is an associate research professor in the Department of Plant Pathology and Environmental Microbiology and director of the Mushroom Research Center and Mushroom Spawn Laboratory at Penn State University. Dr. Pecchia has worked closely with North American mushroom growers, conducting cultivated mushroom research for over 20 years, focusing on topics ranging from button mushroom production, efficiency, and disease control to different aspects of specialty mushroom production. He's currently leading a large USDA-funded project focusing on labor shortage on farms and collaborating on another large project developing disease detection systems for growers to improve their IPM programs. Next up will be Maria Gorgo-Simcox to provide an educational perspective. Maria is a bilingual horticulture extension educator, FSMA produce safety rule lead trainer, and an affiliate faculty instructor for the Plant Pathology and Environmental Microbiology Department at the College of Agricultural Sciences, Penn State University. Maria provides technical assistance to growers with primary emphasis on programs in the areas of vegetable, small fruit, and mushrooms production, green industry, integrated pest management, farm food safety, beginning farming, Latino outreach, and pesticide safety for various agricultural industries in Pennsylvania. Maria identifies strategic educational objectives, develops educational programs utilizing a variety of delivery systems and materials, and evaluates the program impact. To round out today will be Wendy Reed, who will provide lessons learned from conducting produce safety inspections on mushroom farms. Wendy is a food safety inspector with the Bureau of Food Safety Laboratory Sciences for the Pennsylvania Department of Agriculture. She does FDA-commissioned produce safety rule inspections, along with dairy plant farm inspections and seasonal farm labor camps. Wendy has a BS in animal science from Cal Poly and a DVM from UC Davis School of Veterinary Medicine. Prior to joining the Department of Agriculture, she also worked as a small animal veterinarian for over a decade. In the FSMA final rule on produce safety, standards for the growing, harvesting, packing, and holding of produce for human consumption, referred to hereafter as the PSR, Subpart A, provision 112.1B1 includes mushrooms as a food covered by the produce safety rule. As you all may be aware, as compared to other crops such as apples, carrots, or spinach, mushrooms are grown in a manner completely different than other traditional crops. This webinar is intended for produce safety regulatory staff and educators to gain a better understanding of the basics of mushroom growing, harvesting, packing, and holding. The goal is that you should walk away with an improved awareness of these practices in order to apply them during inspectional and educational activities under the produce safety rule. Now I'm going to turn it over to Dr. John Pecchia.
So, welcome everybody. As was mentioned, I've been working with cultivated mushrooms for over 20 years now. And what I'm going to do today is give you a brief overview of how mushrooms are grown. They're very unique in the way they are cultivated. Many people kind of relate them and think of them as in the plant system, and they're very different. The cultivated mushrooms that you find in the stores and at most of the larger restaurant chains will be coming from farms that are cultivating and growing in climate conditions controlled indoors. There is a growing area of small growers that may be doing things outdoors, but the majority of the large cultivation systems and the mushrooms produced in the US are done in an indoor system that's very specific for growing mushrooms. So as most of you know, plants, you put a seed in the ground, they're exposed to sunlight, they photosynthesize, they produce some energy, you fertilize them, and you get fruit or you harvest the entire plant. Bonsai are quite different, that they grow in these filamentous cells called hyphae. And the way they grow, next slide please, is basically they produce enzymes that degrade carbon. So these mushrooms are grown on some sort of carbon base. That substrate varies by variety, and they do not need a lot of nutrients. We don't put a lot of fertilizer to them like you may have produce or different plants. So they release enzymes, they break down the substrate outside of their bodies, then they absorb the nutrients into the body to reproduce and grow. The way we harvest mushrooms or get the mushrooms to fruit really is we inoculate or introduce the vegetative part, that mycelium, into some sort of substrate. It feeds on that substrate, and then we modify the climate conditions to trick the mushroom into forming the fruit bodies. That's what we harvest. So you can kind of think of it like a plant that you have the roots in the bottom and then the fruit forming above ground. The part that's akin to the roots is kind of like that mycelium, where it's just growing vegetatively, it's happy, it's breaking down carbon, nutrients, and just making more of its own tissue. We then trick it somehow into forming the fruit body that we harvest. And that is, this is a picture in the top left is actually an oyster mushroom being produced. The top right is the button mushroom. I may use today this terminology, specialty mushrooms, and we call specialty mushrooms basically everything that's not a white or a brown button portobello. All these other varieties we call specialties. I will touch briefly on a couple of them, on how we grow them, but the majority of what I'm going to focus on is growing the button mushroom and kind of explain to you how that's done, so you know the procedure, some of the safety, the verification points that they have along the way to hopefully produce a safe crop. When you think about what the mushroom's doing when it's forming that fruit body, it's doing that to survive. In nature, if it's happy, it's going to continue to grow vegetatively in the ground or on decaying wood or whatever the case may be. It takes a lot of energy to make this little mushroom that we're going to harvest. We trick that, and what it's doing, it's sexually reproducing in that fruit body or the spores. So like the bottom picture there is portobello. When you flip that cap upside down, what you're looking at are the gills, and inside the gills, that little cartoon blow up above there, are these millions of little spores inside. So the mushrooms, for the most part, that we will deal with, that you'll see in a store or a restaurant, will be mushrooms that produce gills that have these spores. People can be a little hypersensitive to spores if they breathe them in, but typically consuming is not much of an issue. So I told you I'm going to focus on the button mushroom, and the reason for that is it dominates the market if you work in the food industry at all. And we here in Pennsylvania, we grow, now this slide's a little old, but we grow almost 2/3 of the mushrooms here in PA. These farms are not small. They grow the button mushrooms. The second largest producer is California. So if you look at USDA stats, it breaks it down into Pennsylvania, California, and then they lump everybody else into other. So button mushrooms are not really produced commercially in every state across the country. They're localized in regions where it's populated, like Pennsylvania, of course, and then California, and then you'll see some like in Florida, Texas, Washington, Oregon, Illinois, etc. So a lot of the production, say in eastern half of the country, comes out of Pennsylvania and is shipped across the country. We actually do ship from Pennsylvania all the way to California. California produces a lot for the West Coast. We may see some fresh mushrooms imported coming across the border. But we do not import fresh mushrooms from overseas because the shelf life is so short, they don't last. We do, however, see canned and processed mushrooms being imported into this country, possibly from Europe or Asia. The button mushroom, again, we call it agaricus. That's Agaricus bisporus is actually the scientific name. Is dominated by the white buttons, but we're seeing more and more of the brown buttons in the market, and probably because we're seeing more of a demand for the portabella. But still, what you see in the market is going to be primarily be agaricus or in the grocery stores. Majority being white, maybe a quarter of it being brown. But the brown and whites that I'm going to talk about it are grown the same way for the most part. They're on the same substrate. We just manipulate the environment maybe a little different to affect how many mushrooms are forming on the beds. If you look at USDA stats, it says there's over, around 300 growers, commercial growers. Agaricus growers are a very small percentage of that, less than a third, even quite a bit lower than 100 actually. In the US, though, for the button mushrooms, most of what they're growing is going to the fresh market, not the processed because of the price difference that they get. So they're growing, harvesting, packing, and getting the mushrooms out the door very quickly because of the short shelf life. And I told you, not every state has a farm. If you look at this breakdown, and this fluctuates a little bit, this is about 2 years old. The farms are very large. So you have a small percentage of companies producing large volumes of mushrooms that supply restaurants and grocery stores and the government across the country. We have very few small agaricus farms. We do have a lot of the small specialty farms, and that's something that's actually hard to get a handle on who they are and where they are, because they're popping up quite often. This is just the quick data to show you the size of the specialty mushroom sales in the US. And I quit in 2021. I could update this, but when COVID hit, kind of these numbers got all out of whack, and it's not really the same trend anymore, but it has rebounded some. When we talk about specialties, again, everything other than agaricus, the major players are the oyster and the shiitake. So the top left is a yellow oyster, small percentage. It's just grown for eye appeal primarily and get mixed in these specialty bags. Gray oyster is the dominant one. The one on the top right is shiitake, and then the bottom right are king oysters. I would say shiitake, that's on a traditional log, and that's what a lot of people think of with shiitake, and I'll touch on how we grow them in a second. But really, most of the commercial shiitake is grown indoors, not outside. Here's one you can find in the stores. You don't see it in a restaurant very often. And all these specialty mushrooms that I'm going to touch on real quickly here, the procedure is similar. The formula may vary by variety, but the concept is with maitake, for example, this is what you can actually find in the wild in the Northeast. Also called hen of the woods, Scrofola frondosa is the scientific name. We have a specific formula. It's a sawdust-based formula. Every grower has a kind of a unique twist on their formula, but you have a formula, you mix it together. You either do typically a thorough pasteurization. Some may actually sterilize, but it takes a lot of energy to do that. So they do a thorough pasteurization, heat exposure. They cool it down. It's inoculated with basically what we call spawn. It's that mycelium, pure culture mycelium, and it gets added into the substrate. Puts in a room like this where it's climate controlled, extremely high humidity for all these varieties. We keep humidity up in the 90s, up to the high 90s. We control the temperature, we control the lighting. And again, we manipulate the environment a little bit. It colonizes. This mushroom particularly is about I would say 2.5 to 3 months until we harvest. Harvested by hand. You can see the fruit bodies is 1 or 2 per bag. Typically, they kind of just pop them off, put them in a plastic container, and then send them to the house where they're actually packing them. This is lion's mane, grown similar conditions in a bag. We take raw materials, in this case, hardwood sawdust base with a few other things. We, again, heat treat it to pasteurize it at a minimum, get spawned or inoculated. Crop cycle for this, typically from the point you inoculate to the point you harvest, is 5 to 6 weeks. Similar climate conditions, high humidity, temperatures in the growing room might be in the 60s, 70s. And then you can see those little clusters forming on the side of the bag, and they'll pop these off. This is one we're starting to see a lot of interest in, and you're starting to see more small scale production with these diversified growers, these hobby growers, because there's a lot of popular interest with this mushroom. Recently, a few years ago, a couple papers came out showing some correlation with consumption of, this is called hericium, and potential help with dementia and Alzheimer's. So getting a lot of popularity. So you're starting to see a lot of these smaller growers that are popping up all over the country, starting to grow these themselves and then sell them at the local market, or make some sort of end product where they're making pills, capsules, powders, etc. out of these. That is not something I know anything about. We do not do that here. We do not do work with that here at Penn State. This shows you probably one of the top two specialty mushrooms that you'll see in the oyster. This is one, it's hard not to go to a farmer's market across the country and see it. So we have a lot of small specialty growers. When they're getting into mushroom production, this is the one they start with. Commercially, the growers are pretty efficient at this. They will have a formula. This one's actually typically a straw cottonseed hull mix. The small diversified growers, a lot of times we use a sawdust base, but the large commercial farms typically use a straw base mixed with cottonseed hulls. Again, heat treated. Everybody does it a little differently. It might be heated up to 160 for 4 to 6 hours. Once it cools down, they inoculate it, keep it in a climate controlled growing room, again, high humidity, similar temperatures in the 70s for the most part in the air, down into the 60s to fruit it. You get these clusters forming on the outside of the bag. They'll pop the clusters off, put it in what we call a lug, take it to the pack house. Similar with the yellow oysters. The yellows may be grown a little differently, but similar climate for the most part. This is one you don't see as much. I just wanted to put it up here. You can see it. You're starting to see it more in the local diversified growers. It's a king oyster. This one's grown on a sawdust base, open the bag, climate controlled, very similar. This is one, the shiitake cultivation. The picture on the left, this is where you'll see a lot of, I would say, smaller growers or people just getting into it. They'll grow it on actually a true log, different varieties. They'll drill a hole in it, inoculate it, cover it up with wax, let it outside, induce fruiting by basically soaking it in water, harvest it, and you can find people selling these mushrooms locally at restaurants and farmers markets. The one on the right is more of a commercial production system where it's on the sawdust base, goes through a heat treatment like pasteurization, inoculated, grown in a climate controlled growing room. I will say a large majority of the commercial shiitake production that are grown on what we call sawdust logs are actually logs that are being imported from China right now. Not actually made here in the States, because the growers here, even the large growers, can import truckloads, containers full of these frozen, and warm them up and harvest mushrooms off them for less cost than they can do it themselves. So we are seeing a lot of mushrooms that are grown this way on imported logs. Even with the oyster mushrooms, the gray oyster, we're starting to see them being imported in bags, kind of ready to fruit, coming out of China as well. This just shows you the production, and not near as much volume. That's why it's more of a hobby on the right side versus the commercial production on the left side, where they'll just pull these off that artificial log, and they can re-soak the log, get a second flush. Basically what they'll do with that log when they're ready to fruit it is submerge it, keep it submerged for anywhere from 4 to 12 hours, depending on the stage. Pull it out, put it on a shelf in the climate controlled growing room, and then harvest within about a week or so. The Agaricus bisporus cultivation dominates the market. Again, we're going to call it Creminis, Portobellas, and the white buttons all Agaricus for short. Is a much more complicated production system than the specialties. And again, most of these farms are very large. There are several stages necessary in substrate preparation to grow the button mushroom that typically prevents somebody from just doing this in their backyard and selling locally. The first stage is what we call phase 1 composting. So the objective of phase 1 composting is to make a selective substrate that holds a lot of water for the mushroom. And if you've done any kind of composting before, most of the time we think of composting as breaking down some sort of waste, whether it's grass, leaf trimmings, manures, etc. And the idea there is to break it down to make a soil-like, stable material as quickly as possible. That's typically done composting at temperatures maybe around 140, 145 Fahrenheit. That is not our goal. Our goal is to conserve the carbon, make it selective for the button mushroom. Everybody does this a little differently on what raw materials they use, how long they compost, but the basis is still kind of the same. They have some sort of a carbohydrate source, and that's the main ingredient. Typically in the US, it's wheat straw or wheat straw bedded horse manure. In the eastern half of the US and eastern Canada, we use a lot of mulch grass hay because it's available. And that's typically the primary carbon source. Those other things I have listed here can be utilized, but it's not as common. Then we have to add a nitrogen to it. A little bit of protein, not a lot. Typically, poultry manure is used globally because it's available and inexpensive. Growers, composters can use different meals, soybean meal, cottonseed meal. You can use urea, but typically the base is some sort of straw or grass hay. Add poultry manure to it, and then I have on the title plus gypsum. Gypsum's ground, it's drywall basically. It's calcium sulfate, but we use agricultural gypsum. And you mix these materials together and it goes through a self-heating process. There's two ways that this is done. The traditional method on the bottom right here, which is passive aeration. It's done in typically what people call a windrow. In our industry, we call it a rick. You can see it kind of looks like a long loaf of bread. So there's a specialized turner that goes through, mixes these materials, and it can be as long as the composting pad is. The idea here is you mix these raw materials together, you give them water, the microbes are already present, they start decomposing, breaking down the carbon, generates heat. As it generates heat, fresh air comes in from the side, provides oxygen, goes up through the center. It's called a chimney effect. That's passive aeration. That's historically the way it's done here in the States. But over the last 20, 25 years, a lot of the composting operations are converting over, not all of them, into a system like that top picture. And what that is, that's a forced aerated system. We call it a bunker. The idea here is the bottom of the concrete floor of that bunker has pipes that blow air into the compost. The idea is to minimize the chances of going anaerobic because the microbes are using oxygen. We are seeing a conversion of more and more of the composting operations going to these aerated bunkers, but they're expensive. They can get more compost in a smaller footprint, though, on a surface area outside by doing so. So, high temperature composting, I said for manure composting, you might see 140, 145. This composting temperature is typically reaching 170 to 180 plus. 170 to 180, okay? So, plenty hot to pasteurize the substrate, you would think. And it is in the core of the pile. The problem is with those high temperatures, whether it's a rick, which is like that windrow, or a forced aerated system, there is a temperature stratification where the bottom of the pile is cooler. For example, in that aerated bunker, you're blowing air into the bottom of it. So, you know, in February, that air could be 10 below zero in the north. And you're going to have an area where things can survive that we don't want to survive. The focus has always been on pathogens of the mushroom. So yeah, we're growing a mushroom. There are fungal pathogens, bacterial pathogens, all these other things that are a problem for the growers. I'm not even talking about human pathogens yet. So the industry has always taken that substrate that's gone through a phase 1 composting and gone through a pasteurization phase with it. And it can be done one of two ways. They can put the compost into a growing room. And the growing room basically is like a bed system, maybe 4.5 feet wide. The beds might be maybe 10 inches high. And there'll be 4 rows of these beds, 6, 7 beds high in the growing room. They'll inject steam into the room to artificially raise the compost temperature up to 140 and hold it there to pasteurize the substrate, to get rid of the mushroom pathogens. That's traditionally the way it's done. Many of the growers are going over to a system now, instead of pasteurizing in a growing room where they inject steam into the room, they do a bulk pasteurization like that picture on the bottom. So you put the compost back into a container of some sort. This is a very small container at Penn State. And again, the microbial activity self-heats. The objective of phase 2, the first objective is to pasteurize the substrate. We want to make sure we get rid of all the pathogens of the mushroom, which just so happens will destroy any of the human pathogens found in our raw materials. You know, we're dealing with horse manure, poultry manure, etc. So this pasteurization step is a critical point to ensure not only do they not have mushroom pathogen problems, but it's a food safety step. Not only is the compost getting up to temperature, say 140 for 4 to 6 hours. Again, everybody does this a little differently. It's high humidity, close to 100% humidity in that substrate with that temperature. Plus, there's a lot of ammonia in there. So between the ammonia, the humidity, and the temperature, it's killing off the pathogens we don't want. So after pasteurization at 140, we drop the temperature down to 118. That's called conditioning. There's ammonia coming out of that pile. The ammonia would be toxic to the mushroom during that conditioning phase. At 118, the microbes actually are converting that free ammonia into protein that the mushroom can use then as a food source. In a bulk system like this, the air, the fresh air that's coming into the tunnel, into that compost, is actually going through a HEPA filter, so we don't recontaminate after we pasteurize. What are the pasteurization requirements? Again, it varies a little bit. That middle green box, growers that are still doing pasteurization in the growing room where they artificially inject steam, they typically know the coolest point in that growing room. And they will monitor that cool point until that substrate is up to 140 in that place for so many hours. But by doing so, there are other areas in that house that get hotter. So they're getting what we call override, where temperatures are reaching 150, 155, almost 160. Because of that, it's actually reducing the beneficial microbes. So the phase 2 process takes longer to get rid of the ammonia in that scenario. In these tunnels, much more precise temperature control, and pasteurization can, again, it varies 2 to 4 hours typically at that 60 or 140 Fahrenheit temperature. So this just shows you kind of an override, and it's kind of a chart showing you phase 2 temperatures. All those colored probes that are really high are compost temperatures. The yellow flat line is our set point at 140, and you can see that we have temperatures, in this case, reaching 150s. The blue line is the air temperature. So we get a lot of override in the growing room. So we're definitely getting those 140 plus in the growing room, but it takes a lot longer, unfortunately. And it takes a lot of energy to blow steam in there. So that's why we're seeing a lot of growers switch over to doing bulk pasteurization. Let the microbes do the work and make the energy. Because we've done this for a long time, and we've been doing it with the goal of eliminating mushroom pathogens, as food safety has become more, aware over the last couple of decades, we did a study probably 15 to 20 years ago at Penn State where a faculty member in food science, we spiked the phase 2 compost with bags of pathogens, and I don't remember what they actually used. I think it was E. coli, maybe out of 157, but they put that inside the compost to ensure that the human pathogens, were not surviving the phase 2 temperature profile. And then when the Food Safety Modernization Act came through and the regs were coming out about compost use, we did another study collaborating with food scientists, going out to farms, the commercial industry, sampling the compost as it's coming out of these tunnels after pasteurization. So that picture on the top is the guy on the right is actually reaching in, grabbing the compost as it's coming out of this big bulk phase 2 pasteurization system as a confirmation to show that no human pathogens are surviving any of these temperature time combinations. Hopefully at this point, the composting operations have made and pasteurized the compost that's free of pathogens for the mushroom as well as human consumption. I will tell you that not all commercial agaricus growers are making their own compost, and most are not actually. There are several very large composting operations that will sell their compost. They'll do the bulk phase 1 or any kind of phase 1. They'll ship phase 1 compost to a grower where they'll pasteurize in their house, or they will do the bulk phase 2 composting. That slide I just showed you. They'll bring it out. They'll add what's called spawn, this mycelium, into it and ship that to a grower who will then put this into their house. So spawn is the idea of somehow you have to inoculate. We don't use seeds. So we take that pure culture of mycelium, kind of like the roots of the fungus. We grow it on sterilized grain historically. In this case, it's millet, this picture on the top. We let it colonize that grain, and then we use that grain as a carbohydrate source and a carrier to inoculate the crop. The commercial agaricus growers in the US are not making their own spawn. They rely on basically 3 large commercial, kind of like a seed company, spawn companies, from which they buy this material. So they get it in bags. It's already colonized, this grain, or we have a non-grain, but similar concept now. The bags have filter patches on them so it can respire. It's breathing, but it prevents spores from coming into the bag. Once it's colonized, it can be stored refrigerated, shipped refrigerated to a grower, and then inoculated on the farm. The way this is done is large scale sterilization. These are 2 different companies, 2 different methods they do it. The one on the right is a V blender, it's called. The one on the left is a kind of a flow through system. where they are truly sterilizing the substrate, inoculating with a pure culture. They fill these bags. Again, this is one of the rooms. The bags go into a climate controlled growing room. They monitor temperature. And once it's fully colonized, they will ship these refrigerated to the growers, the composters, or the growers, depending who's doing the inoculation. The quality control at the spawn companies is extremely high. I've actually never even been in where they're bagging the substrate because I don't want to go through the cleaning, changing of clothes process to get in there, because they realize that they can easily have a large contamination problem. So the filtration, the sanitation, the quality control of these facilities is phenomenal. That being said, the smaller diversified growers that we're seeing pop up around the country that are selling maybe to farmers markets or the restaurants, they can get their spawn anywhere. They can get it on eBay. They can make it themselves, which some do. So there's a lot more question with the smaller diversified growers than the larger commercial operations. Once they inoculate the substrate, again, this is a composted substrate, gone through 2 phases of composting. It's spawned or inoculated. And then they just control the climate, high humidity, temperatures in the room can be in the low 50s, temperature in that substrate during this colonization period, we call spawn run, typically runs in the mid to upper 70s, low 80s. Typically takes roughly 2 weeks, and then you'll see it's completely colonized with hopefully a pure culture of the Agaricus mycelium at this point. In the grow room, very high humidity, very high CO2 during this process. So after complete colonization, then they come in and they'll put a layer of peat moss on top. So if you're looking, as you're looking at this slide, I don't know if you can see my pointer or not, but about halfway up, you see it's a lighter color and it's all white and fuzzy. That's the substrate that's been colonized underneath. That top dark black is sphagnum peat moss. So sphagnum peat moss has a low pH, it's acidic. So growers typically will add an agricultural crushed limestone to the peat moss to bring the pH up to near 7 to 7.5. Bring it to near saturation with water, and then apply it roughly 1.5 to 2 inches thick on top of that colonized substrate. They basically just control the environment again, control the temperature, the humidity, the CO2. They will water this on a regular basis. Now, everybody does this a little different, but the frequency and the timing of the watering is based on a very subjective interpretation of the growth. But they'll go in and they'll water it by hand in the old rooms and even most of the newer ones. This is a really new facility. With these new facilities, they can have what they call a watering tree. They will walk down. They can do it manually or automatic that rides on these rails and waters all the beds at once. Or most of the farms still water by hand, like you would in a greenhouse. So that was a newer farm, and we're seeing a few of these. These new farms are very large. They're very expensive. The old farms, and these are typically just found in Pennsylvania. We call these Pennsylvania doubles. What you're looking at in the bottom right is an old picture of a Pennsylvania double. And what that is a blockhouse. Inside that blockhouse, you can see the cartoon picture on top. Those shelvings are made out of wood, and you'll basically have 4 lengths of these wooden shelves, 6 high in one growing room. These old block buildings that are, some of them can be 80 plus years old, are still being utilized today. The wooden bed boards, depending on what they use, typically are switched out every 4 or 5 years roughly. The aluminum beds, the benefit is they don't have to switch it out. The aluminum beds are also much easier to clean. That casing layer on top, they'll water and water. As the mushrooms start forming these little pins, these fruit bodies you see in the bottom, once they get that size like an eraser, they double in size every day. And then they get to that what you see on top and they're ready to harvest. The mushrooms in the US are still harvested by hand. And typically, roughly 2 weeks, give or take, after they put that peat moss on, they're ready to harvest. They'll typically harvest one room, what we call first flush of mushrooms coming on, maybe over a 3, 4, 5 day period, all picked by hand once a day. Some farms will actually send pickers in and pick twice a day because they grow so fast. They'll pick the bigger ones in the morning, they'll come back later in the day, pick again. But they'll pick by hand, they'll cut off the stump or the little part that adheres to the peat moss, put the mushrooms either in a bulk bin that might hold 10 pounds, or some will direct pick by size into the tills that you would see in a grocery store, for example. Okay. They will water back on these beds on a regular basis. Next week, they'll get a second flush. So they'll pick this week. It's the first flush of mushrooms picking off. Next week, they'll get a second flush coming off. And then some do, some don't. We'll pick a third flush where they get a third week of picking coming off. The yield keeps dropping. So some will actually cut it off after 2 weeks. Some will go 3 weeks. So it's very labor intensive, all picked by hand. And then at the end of the shift, somebody will come in and clean the floor up, clean the room up. And somebody will decide if and how much water to put back on the room for tomorrow. So this shows you a picture inside of a house. In this case, this is what we call a newer aluminum shelving system, where the workers, you can see on these picking lorries, the person on the right and on the left, at these different levels, they basically reach in, pick, they're picking bulk into these 10-pound lugs here, and then they stack them up and take them out of the growing room. A normal house is either 8,000 to 10,000 square feet, typically 7 to 8 pounds picked over 3 weeks in that time frame. So in one house, you know, you can be looking at 70, 80,000 pounds of mushrooms coming out over 3 weeks. And then most of these, well, all of these agaricus farms have multiple houses on the same location or in a general vicinity of one another. Now, I'm not a packing expert. I'm not getting into the details of packing and processing, but typically there are centralized processing facilities. Some have their own, some they're centralized in these regions. They'll go to the pack houses. Typically, you're vacuum cooled to get them down very quickly. The temperature down in them because of the shelf life being so short. Some are shipped out bulk. Some are end weighed so they're the right weight, overwrapped, palletized. And typically, most of these mushrooms are going out the door in the truck to wherever their end destination is, whether it's a distribution center or directly to a Walmart or whatever, within 24 hours. At the end of the cropping in that growing room, they inject steam into the growing room. Typically do this roughly about a day with fans circulating, and they do that to pasteurize the substrate where the mushrooms are growing, to kill those mushrooms, to kill any pests or pathogens, mushroom pathogens that have grown in there during that cropping cycle. They empty the room, they clean it, and the BMP's best management practice is to inject steam into the room again, empty, at least with the wooden beds, sanitize it, and then they bring the next cropping. So they'll use the same growing room multiple times per year, anywhere from say 4 to 6.5, roughly 4.5 to 6.5 times, 7 times per year. The same room gets used over and over again. The substrate coming out is what you can buy for soil amendment, gardens, etc., called spent mushroom substrate, mushroom compost, etc. So that's the overview of agaricus, a quick overview of some of the specialties. I know we should have some time at the end, and you can feel free to ask me anything you want. I may know the answer. If it's about production, I probably can help you. Packing, not quite as much. So with that, I'm going to pass the baton over to Maria Gorgo.
Thank you, John. Good afternoon, everyone. As Kristin mentioned before, I'm a horticulture extension educator for Penn State Extension, and I work very closely with the mushroom industry, providing educational programming mainly on integrated pest management, pesticide safety, and farm food safety. For the sake of time today and to allow more time for the question and answer session of this webinar, I'm going to talk briefly about how the produce safety rule applies to mushroom growing. In regards to farm food safety, fortunately, the mushroom industry has been in the forefront for many years now. It is important to stand out that the industry-driven standards established in the Mushroom Good Agriculture Practices Program, or MGAP, meet or exceed most of the requirements in the product safety rule. Some of the product safety rule key areas that mushroom growers should pay more attention to are, first, the agricultural water. Since the product safety rule applies to pre or post-harvest water that is intended to or likely to contact the crop or crop contact surfaces, and since mushrooms are typically irrigated with spray methods, the quality of the water used for this purpose is regulated by the FSMA PSR. So when growers conduct a risk assessment, it is key for them to lower the risk by looking into the water source. This is not new for the mushroom growers, since surface water, which can often contain high levels of E. coli, is not permitted under MGAP standards. On the other hand, the lower risk well or municipal water containing no E. coli is already the industry standard for irrigation and cleaning. And as an additional safeguard, many growers treat the agricultural water with a sanitizer to avoid any contamination. However, they must periodically monitor sanitizer levels to assure that the treated water is consistently safe. In the case of raw and composted animal manure, mushroom substrate prepared from ingredients that include raw animal manure is regulated under the Produce Safety Rule. Fortunately, the mushroom growers use an FDA-approved scientifically validated process that demonstrates the complete elimination of human pathogens. This research study mentioned by John before was carried out at Penn State by Dr. Will and Dr. Luc Laborde back in 2013 and has demonstrated the complete reduction of Listeria monocytogenes, E. coli 0157H7, and Salmonellosis species during a standard 6-day phase 2 composting process that includes a pasteurization step of at least 140 degrees for 2 hours. In addition, the finished substrate can be used without any requirement for microbial testing or application interval restrictions. Therefore, phase 2 composting process can be an effective control measure for eliminating risk associated with the use of composted animal manures during the mushroom production. Growers are encouraged to validate and verify their own composting processes through periodic microbial testing for pathogens and to conduct studies to assure uniform distribution of substrate monitoring temperatures during phase 2. When talking about worker health and hygiene, workers are the first line of defense in regards to food safety. Their requirements include taking measures to prevent contamination of produce and food contact surfaces. These are also already addressed in MGAP standards, and mushroom growers who follow them should have no problems with the FDA standards. The growing, harvesting, and post-harvest practices section describes standards for preventing environmental contamination of produce and food contact surfaces, and there is an emphasis on the necessity for regular cleaning and sanitizing of food and non-food contact surfaces. This may be new to some produce growers, but mushroom growers who diligently follow MGAP or other audit standards should be well prepared to meet these FDA standards. And then finally, we also have the Produce Safety Rule training requirements. Once again, MGAP has also addressed these needs. Mushroom growers conduct regular in-house trainings and attend industry food safety trainings, workshops, or seminars. In addition, Penn State Extension FSMA team has been offering Produce Safety Alliance certification courses since 2018, and we continue to offer in-person and online courses every year available in both English and Spanish. So here you can see the Penn State Extension website with several resources. There's one article called Mushroom Gaps and Audits and FSMA Resources, and you can see the link right here. This article lists the information and resources needed to meet good agriculture practices and Food Safety Modernization Act standards specific for the mushroom industry. You will find Penn State commodity-specific recommendation and science-based information for growers and inspectors, such as basic procedures for agaricus mushroom growing, validating thermal sanitation of mushroom disc slicing equipment, the impact of FDA produce safety standards on mushroom substrate composting, also talks about sphagnum peat-based casing soils, and the eradication of Listeria monocytogenes from mushroom slicing and packaging environment. And this is our Penn State Extension horticulture mushroom team. We have Dr. Dave Byer and Dr. John Pecchia, and both work for the Plant Pathology and Environmental Microbiology Department. Dr. Michael Wolfin, he is with the Entomology Department. Dr. Luc Laborde, who I just mentioned, he is with the Food Science Department. And then myself, Maria Gorgo-Simcox, I'm an extension educator and also the mushroom team leader. So thank you. And now I would like to turn it over to Wendy Reed from the Pennsylvania Department of Agriculture.
Thank you, Maria. So everyone is an expert on growing mushrooms at this point. You know all the terminology, you know all the studies, you should be able to go out there and develop your own farm, and we will come and clap you on the back and say, good job. So there's a quiz coming up in just a minute, and we're going to test your knowledge. No, I'm just kidding. So if anyone came through here and went, what is a cycle, a spawn? What is the inoculation? What is a flush? What's this substrate? What's this pasteurization cycle? Phase 1 versus phase 2, and have like a whole lot of terminology going through their head and felt like they just took a foreign language class, then welcome to mushrooms and have a nice day, and you're doing just fine. I have to admit that when my first day going out onto a mushroom farm with another inspector, that's pretty much how I felt. You could have seen crops grown out in fields, greenhouses. You could be an expert on aquaponics or hydroponics, and this is a whole new world. And so I think just understanding that it is different, that there are things that you are going to learn just as much as you're going to teach, is the appropriate attitude to have when you come onto a mushroom farm. And no, I can't tell you every single one of the mushrooms that I have on here. I believe the one on the left is something that's grown in the wild that I would not advise picking. That's probably little brown creminis in the middle. And John will have to tell me what's on the right, but it looks like it might be shiitakes grown on a sawdust log. So as an inspector, I think it's really important to have an appropriate attitude coming onto the farm. You are there to inspect, you are there to educate, but you're also there to learn. If you are not humble and curious about what your farmers are doing, you might not have the right attitude going on to farms. You could come up on your 17th, 20th mushroom farm of the last 2 months, and it's going to be something new you're going to learn every time. There is something different that they might be incorporating, a different method that they're shipping, a different method that they are cooling or not cooling there at the farm, the way they train their workers, what they do with their equipment. There is always something to learn. And I think that if you go in willing to learn and to ask questions and to be humble about your knowledge, that the farmers and the managers are going to be that much more interested in learning from what your perspective is about food safety too. And just realize they might be in an indoor environment, but farming is probably one of the most difficult jobs that there is out there. There are a lot of cost factors from suppliers to also who they're shipping to and the demands on the market that they really don't have a lot of control over. And as John was mentioning, there's a lot of difficulties in obtaining enough workforce. This is a very difficult, long, strenuous type of atmosphere. You're working as a worker, they're in the dark a lot of times. It's a fairly dirty kind of environment because they're bent over these different substrates harvesting. So an appreciation of the farmer and an understanding of where they're coming from can be very, very helpful for you on the farm. Coming from my background, I would say that there's very few inspectors that probably have my scientific background as far as on animal safety. And that doesn't mean that they're not experts in their fields as far as what they're looking at, but I just have a different approach and I really love the scientific aspect of it, but I'm also always really wanting to learn. So when I look at a farm, one of the first things I'm really looking at is what is the buy-in on food safety that that farmer already has? Have they been able to obtain training from the AMI, the American Mushroom Institute that Maria mentioned, the really large trade organization? They are really a huge forerunner of food safety in the mushroom area. Have they been able to obtain produce grower safety trainings regarding the produce safety role? How many people are involved with the safety training on the farm? Is the people that are in the managerial side, are they speaking the same language as the workers? So you really have to kind of figure out where that farm is at, so then you can decide what the approach that's going to be best as far as explaining and walking along a path of food safety that'll help to implement some of these rules and get them potentially started or just advance some of the areas where they might be doing a really good job. Also understand how these markets are interconnected. And like John was mentioning, Southeast Pennsylvania, which is where I usually do a lot of my focus on inspections, has a huge number of farms. And I will say that even though they might not all be connected by family, they are in a way like a large term extended family. They spar against each other, they compete against each other, but they also work together. One might produce the compost, another one might do some of the other phases. Somebody else might have the peat moss and the limestone that they supply. Other people are involved with the different agricultural, the post substrate and where they go to nurseries. So it's a pretty large organization. And also just respecting that all the farms talk to each other. So what you talk to about one farmer on one farm is also going to spread around the entire area of where you're at. So keeping your message simple, but at the same time consistent is a really good thing. Of the mushroom farms I have visited so far, greater than 90% of the workers are of Hispanic descent. Some have not lived in the United States for a long time. Others come up here for a certain number of months out of the year. So making sure that the people that you are doing your inspection with are fluent in English is actually really important. You want to make sure that the message that you're bringing along with you can be fully interpreted and also then explained to anyone else on the farm. And I think, honestly, we still need to work more on having, greater Spanish speaking trainings. The more we can continue with that, I think is really helpful. But there's usually one or two people that work sometimes for multiple farms. And if that person disappears, then their whole food safety program disappears with them. So encouraging other people to get the training and working with them to find Spanish speaking training is also very good. I mentioned again, AMI, the American Mushroom Institute. We will have a link that'll come out later that if someone's interested in learning more about this organization, we'll send you some information on them. And then I find not a lot, but there's a certain number of fly-by-night operations. People that come in that decide they think they know what they're doing. They've been working in mushroom houses for a while. They rent a few these what we call doubles or houses that are out on the market, and they decide they're just going to kind of sneak into the market and start selling mushrooms. And they can be a little bit difficult to track down. A lot of times their food safety training might not be the same as owners or managers that they used to work with. And those are an area that's difficult to try and find. Usually by the time I find them, they've either disappeared or they've moved on to somewhere else. Market conditions usually dictate that they don't end up usually staying around for a long period of time, but we're always on the lookout to make sure that everyone has the appropriate training. And then just understanding, I have down this SFLC, that stands for Seasonal Farm Labor Camps, which I also inspect as part of my duties. And these are a lot of times are the housing units that the workers are staying in while they're there. So understanding how that unit facilitates and works with the operation is actually pretty key, because there might not be a standardized break room or a standardized bathroom or certain hand washing facilities that are always accessible. A lot of times these workers might go back to their homes for their lunches. The tools might go with them. So you have to kind of be aware of where some of these things are happening, the travels of the people on the actual farm. And it's just some different things to be aware of. So those are just a few things. I want to make sure that we leave plenty of time for the questions, because I'm sure there's 1,000 questions about mushrooms. But I think the key points is being an approachable inspector, being a resource, an educator, and someone who's willing to learn, and just being made willing to be out there. And that makes people a lot less worried and concerned that, we might come down with a hammer, but we're going to teach them and help them along the process and make sure that they get to the right spot, so that we care about them having a safe product just as much as they do. And thank you very much. I'm going to pass it back to Kristin. I think we're going to move on to questions.
Thanks, Wendy. And thanks to all of our speakers today. It's been wonderful information. This slide here is just some additional resources. I think actually most of these have already been provided to you. We will be, with the recording, we will be providing the links and any other materials that you've seen and heard about today during the webinar. This presentation that we had today was primarily focused on white or button mushrooms, but we did share or Dr. Pecchia did share some information on specialty mushrooms. So we did want to share some current publications on research undertaken to better understand the outbreaks linked to Enoki mushrooms and wood ear mushrooms. FDA has conducted research to better understand how pathogens contaminate these products, and if present, how these pathogens behave when exposed to different storage temperatures as well as dehydration. We will also include these references in the email to you after this webinar. Okay, so now's our time to go ahead and open it up to your questions. We do have a bunch of questions that came in. I'm going to start with a couple just to clarify, because we have had quite a few people with the same questions. The first one that I wanted to address is how is the produce safety rule applied to foraged mushrooms? And all mushrooms, including wild foraged mushrooms, are covered produce under the produce safety rule. And wild forage mushrooms would need to adhere to all relevant provisions related to harvesting, packing, and holding. I've got one for John here. So somebody just wanted to clarify, they were wondering if 2/3 of the growers are actually specialty mushroom growers.
That number I said 2/3. So that is taken from the USDA statistics. They do a survey for anybody that they document as a commercial grower. So there are many more commercial specialty growers than agaricus growers. They're just very small in size for the most part. And it probably underestimates how many specialty growers are out there selling mushrooms.
Thank you. I'm not sure who wants to answer this one, but somebody just wanted clarification on what is a flush.
Okay, so a flush is basically considered like a harvesting period. So when we're growing button mushrooms, they grow, they're fruiting, and then they all come up within 3 or 4 days, and we pick all these mushrooms this week. That 1 week is one flush, or we call it a break also. So this is the first flush, because they all came up, we pick them off, we water that crop, and then next week we'll pick again, and then we get a second wave or a second flush of mushrooms fruiting. And again, you can continue to do it for a long time, but the yield keeps dropping. So commercially, the growers typically pick 2 or 3 flushes. So they'll pick over 2 or 3 weeks of, say, 3 or 4 days of harvesting per week. Same with the oyster mushrooms, where you might pick them off the bags this week over a couple of days. Then you wait a week to 10 days, and you get another surge of fruit bodies of these mushrooms coming out that's ready to harvest. That's that second flush, say, in a week or 10 days.
Thank you. This one for Wendy. What is the risk of transfer from the employee shoes to the mushrooms? Have you seen any instances where that might be a problem during some inspections?
We actually watch kind of carefully where the workers and harvesters are putting their feet, because they are potentially walking through the floor and some substrate that might be on the floor, or some stumps that might have been discarded. So we try and make sure that they're very careful about not putting their feet onto areas of the side rails where they're going to potentially use their hands for gripping the side rails to reach further in to actually harvest the mushrooms. A lot of times when they're trained, they're given specific training about how to get into that area. They also usually have hair nets, beard nets, gloves. They're actually usually really well trained as far as protecting the mushrooms and also protecting themselves from recontaminating areas. So we do watch that specifically, yes, especially looking for, a wet hallway and wet drain areas they walked through to make sure they're not transmitting Listeria back into that area.
Thanks, Wendy. How are organic mushrooms grown differently from regular mushrooms? Are there pesticides used in regular mushroom growing process?
I'll take that one. So there are organically produced commercial farms. They have, as you would imagine, they have more limitations on what they have available to them for use as a pesticide. The industry as a whole has very few chemicals labeled for use because it's a specialty crop. And also because the growing cycle is pretty quick. It's not an industry that goes in after the fact and sprays once you see a problem. So most of their disease control, mushroom disease control, is done through hygiene and sanitation. And again, that could pasteurization. There are chemicals labeled for use, yes. And it does vary from organic to conventional farms.
Thank you. And John, actually, the next one's probably for you too. Can you further describe the cleaning and sanitizing process?
Again, it varies by farm. So the growers are pretty keenly aware that they need to have all the organic matter removed between crops and in their equipment that handles clean material. And clean material is anything after it's been pasteurized, because they realize that that just leads to more mushroom disease problems for them. So, for example, like the old wooden farms, those wooden beds, they will physically remove all what we call stumps, all the dead organic matter, mushrooms on the floors, etc., during the harvesting and cropping period of a few weeks. When they're done, they will inject steam into that room to pasteurize it and then scrub it and take the product out. There are different chemicals labeled for use on contact surfaces, non-contact surfaces, whether they're organic or conventional. And I can't tell you what the entire list is. But yeah, there are chemicals they can use in contact and non-contact surfaces.
Okay, one question. What happens with the SMS and SMC after production?
So Pennsylvania, we produce an incredible amount of mushroom compost coming out of the doors after it's been pasteurized. A lot of it is agronomically land applied. Some of it is further composted into potting mixes. One company is very actively composting, making green roof material. But in Pennsylvania, it is a challenge because we produce so much of it in basically a couple counties in southeast Pennsylvania. But it's a great soil amendment to add organic matter into the soil. It's not real high in NPK, nitrogen, phosphorus, potassium. It can be a little high in salts.
I'm not sure who wants to answer this one, but a question is, can you expand more on the sphagnum peat moss not allowing listeria to grow, and where can they find that study?
I can take this one. I think I mentioned this research study in my slides. If they go to the Penn State Extension website and they look for farm food safety, they're gonna find the list of all the research studies and the explanation.
So basically what they showed is there's a natural microflora in the sphagnum peat moss that helps suppress. Dr. Luke Laborde did this work, and he, in his work with his grad students, showed that that microflora actually helps suppress listeria if it does get introduced into the casing material. Versus if you would actually think, okay, because it's a ready-to-eat product, we're better off maybe pasteurizing the peat moss first. And that actually is detrimental because you're wiping out that natural microflora that's good to kind of suppress these pathogens.
The next one I will take. At what point would specialty mushroom farm require a produce safety rule inspection? If they are doing any growing, harvesting, packing, or holding, anything within that's covered under the produce safety rule would require a produce safety rule inspection. If mushrooms are stored moist and anaerobic, is there any chance of spore formers like CBOT acting up?
That one's out of my area.
Okay.
I would just say that that's something that I heard different farmers discussing, especially with the packaging and plastic packaging and having air holes. And I would probably look at some of the studies that might have been done looking at that from the American Mushroom Institute, because that's more of an industry discussion that I heard of. That wasn't something that was talked about from our end.
Yes, thank you. Are mushrooms washed with sanitizers before packing?
The fresh pack, they're not washed prior. If they're being processed, they potentially could receive a wash.
One question's asked about resources for new growers, and we can, we'll provide some information when we send out the after webinar email with the recording and educational materials and links. Some farms steam treat their peat moss before casing and some do not. Could you clarify the purpose of this practice?
It's typically not done with fresh sphagnum peat. Historically, they did it years ago, decades ago. But because, like, related to that study that I mentioned with Dr. Laborde, it actually shows that there's a natural microflora that's beneficial, and you're better off not steam pasteurizing. So, and plus it takes a lot of energy. So typically sphagnum peat is not pasteurized prior to use on most commercial agaricus farms.
Okay, next question. Maybe for Wendy, what are the main areas of concern from a food safety standpoint for growing and harvesting mushrooms that an inspector should be aware of?
I think Maria mentioned some of these areas, specifically the water quality, water testing, water sources. We look a lot at the management and the worker training as far as the ability to harvest. Are they following the proper protocols for pasteurizing the rooms and the substrates in such a way that they're making sure that they have a nice, clean environment? A lot of them will even sanitize some of the water they're using to spray over the surface of the mushrooms, just to make sure, not necessarily from a food safety point, but also just to inhibit competing other fungi that might be trying to grow. We're also specifically looking at their harvest tools, their bins, their storage areas, coolers. A lot of it is very similar, just realizing, looking at it from an indoor environment and thinking of the things that could cluster into an indoor environment with the moisture, water, humidity, thinking a lot about Listerium that could be hiding in cracks. What are their cleaning protocols for hallways? What are their cleaning protocols for their trucks? Things of that nature. We're looking at all those areas to make sure they're aware that things can be tracked back and forth.
Maria, do you have anything you'd like to add to that?
No, pretty much the source of the water source and also the food contact surfaces, the knives that are harvesting, I don't know how are being sanitized as well.
Thank you. So for sanitation, what products are specifically labeled for use with mushrooms? Sanidate, for example.
I don't have that list with me. The American Mushroom Institute keeps a list of chemicals that are labeled for use for sanitizing.
So we've got some questions about dried mushrooms, and some manufacturing processing is allowed under the produce safety rule, including the drying and dehydrating of a raw agricultural commodity, in this case mushrooms, without additional manufacturing processing such as slicing. So
I think this would be preventive control. It is not PSR anymore.
are there alternatives to peat moss for casing?
We're testing constantly for that. There's nothing that works as well, I'll put it that way. But there are things that are currently being utilized, yes.
Any recommendations for control points regarding outdoor growing of mushrooms?
You're talking about control points for disease control? Is that, I assume, what they mean?
It's not specific. Either that or food safety, I'm not sure.
I don't specifically, I don't work with outdoor production. I think of anything that's coming in contact with any kind of waste product, pathogens, manures, etc.
I might also consider wildlife or pests that could access that area. Are other people able to access that area? Is there runoff from rain or from other agricultural activities that might be occurring nearby? Just kind of the normal same things that we look at for any other outdoor grown product.
Question about the media on which mushrooms are grown, and I just wanted to clarify that if biological soil amendments of animal origin are used, such as manures, you must follow the requirements in subpart F of the produce safety rule to be in compliance with the produce safety rule. Also, if you're using overhead drip, or because mushrooms are high humidity environments, There's some questions about condensate, and in cases where condensate contacts your covered produce or food contact surfaces, you should consider the originating surface of the condensate a food contact surface, and you should evaluate whether measures to address any potentially contaminated covered produce or food contact surfaces are necessary. Ceilings, overhead pipes, walls, floors, and drains can be maintained in a sanitary condition by ensuring that their surfaces are of a design, construction, and workmanship such that they can be adequately cleaned and properly maintained, and by cleaning and, when necessary and appropriate, sanitizing them. We've gotten through a lot of the produce safety rule type questions. We get some coming in here and there. What are common questions mushroom growers have for us or issues they usually face? So maybe questions, Wendy or Maria, you might get out in the field.
In my case, because we're not doing any reinforcement, it's more like questions regarding diseases or food safety per se. But Wendy, I don't want to put you in the spot. I think maybe he was referring to an inspector.
Yeah, sometimes people are a little bit more hesitant to ask the inspector questions. I think you have to develop that relationship. But honestly, I really see that there is a desire to have more training done in the Spanish language. And I actually have found it difficult to find consistent trainings at this time period. I think they might have been more frequent in the beginning, but we have a lot of turnovers of farms. So I think that is a big topic for me that I see in a lot of my mushroom farms, is having a good buy-in from a lot of different tiers of the management levels of understanding the food safety process.
And when you know that we do offer the training in the FISMA training in Spanish. So when you're out there seeing the farms, please let them know the PSA and Penn State Extension, we are offering these trainings in Spanish.
And just to clarify on the drying and dehydrating, that the harvest definition in the produce safety rule under provision 112.3 includes drying or dehydrating a raw agricultural commodity without additional manufacturing or processing on the farm, such as slicing. What concerns must I know if, and I'm not sure if anybody can answer this, if the nitrogen source is spent grains from brewing or distilling?
For a food safety perspective, I don't know. Depends how they're being utilized. Typically, if it's in a specialty formulation, it's going to be heat treated if you're concerned about pathogens. And if it's in an agaricus system, it's going through the phase 1, phase 2 composting pasteurization process as well. So I'm not sure specifically.
There's been a couple of questions about low heat pasteurization with things such as lime.
That's so the hobby growers that are all over the country and on social media, if they don't have a way to heat, they try this high pH hydrated lime pasteurization process. I don't know if anybody's looked at the food safety around that. It's not a process used by the commercial growers, but it's something you see a lot of the smaller growers online playing with. So I don't know what that does as far as how efficient that is to pasteurize the substrate.
Another question, what size and scale does a specialty mushroom farm require a produce safety rule inspection? I can answer this, or if you'd like to, Wendy, you can do it also. Okay, so basically a farm that grosses over $25,000 adjusted for inflation of produce sales, that's when any farm would be subject to the produce safety rule, but there are a lot of other nuances that go into whether or not you might be qualified exempt or commercial processing exempt or other things. So I would encourage folks to get in touch with their local produce safety team to further identify any answers about whether or not you're covered under the produce safety rule.
I would absolutely agree with that. Even if you're not going to be inspected, there's still a lot of resources that we can give to you. We would like to know that you're out there. We would like to know what you're doing. We'd like to make sure that you know about the training that is required for a manager, even if you're not inspected. And just make sure that you have the knowledge to have a safe product and you know what some of the things are that we're looking at. So I will do educational visits on many farms that might be either slightly under that level or at a higher level, but selling direct to consumers and still might fall under a different exemption. But we are really a good resource, and it's really good to reach out to your state, local, or if you're in an FDA state, and make sure that they know what you're doing and what you're about.
Another question, John, I'm not sure if you can answer this, is there's been some questions about washing mushrooms. As you indicated, most of the larger facilities don't wash them if they're not going for further processing. So what is a good way to wash mushrooms?
If you're talking commercially, I have no idea what they use and how they do it. If you're doing it for home consumption, typically you don't do it until right before you're ready to consume it. But
I would agree.
I don't know
I'd agree with
commercially how they
John.
do what they use.
Yeah, I don't see anybody doing any type of right before harvest or post-harvest wash. That would seem to degrade the mushroom very quickly.
Absolutely. Only the processing.
And I think you went over this, John, with your the composting. Last question I see here is, how is salmonella contamination avoided when you're using poultry manure?
Yeah, the contamination's avoided by thorough phase 2 pasteurization in the composting process.
Well, that's the last question that I see here relating to the produce safety rule and mushrooms. I want to thank our 3 presenters again very much for a wonderful, very informative webinar. We appreciate your time and thank you for joining us today.